Okay, everybody, I think now is the time to start. Uh, can you see my screen?
Yes, we can see the PowerPoint.
Yes, we can see.
Okay, great. You see the first slide about homework set 2 that you already submitted. I'm still looking. So, soon in a day or two, I will let you know the grade for this set of homework as well as the midterm exam. Uh, so, first today, I like to discuss the answers to the questions. So everybody see the first question was consider a control system where the supervisory computer needs to obtain voltage signals from distributed generators located in a smart grid. But those signals have significant amount of harmonics. How might these harmonics influence the functionality of the grid system? Explain your answer. So because it is related to distributed generator, a smart grid, and supervisory computer system. First, let's have a look on diagram. Everybody see this example smart power grid. So I believe before in on class I have showed you this slide. Uh, in this example system, you can see on the top left side there is a wind farm, and right below that there is a solar farm, and right after that below there is supercapacitor energy storage system. On the right side top there is a synchronous generator, which is a conventional type of generator, and that is connected to the distribution grid through some short line. On the rightmost side there is a control device which is called thyristor switched capacitor, TSC. And then on top of that, there is SCADA, supervisory control and data acquisition system. Now the question is, for example, you need to collect the voltage signal. So you are collecting the voltage, but those signals have significant amount of harmonics. So this means that SCADA collected voltage signals from everywhere, but there are harmonics. So how might that affect the control system and the overall grid? So as you know that harmonics, so before we discussed this type of question in terms of time delay, and that you understood well that if there is time delay in the signals, that will degrade the controller performance and hence the overall power grid. So in this case, harmonics means there are higher order of frequency, like 3 times of fundamental frequency, 5 times, 7 times. So this means SCADA will receive distorted signals uh, with lots of oscillating signal. So therefore, it is difficult for the SCADA to make decision based on that distorted signal or with the harmonic signals. Controller cannot properly understand what's the magnitude because there are significant amount of harmonics. Sorry? Hello? Adil? Okay. So what will happen, because there are significant harmonics, so it is difficult for the SCADA to understand the magnitude, and it is difficult to understand whether it is sinusoidal or non-sinusoidal signal. Consequently, the connected controller cannot operate properly. And if any controller cannot operate properly, then the overall grid system will be affected. This means the performance will be degraded. So what did you write to the answer for this question? Question number 1.
I wrote the same thing, but I added that the harmonics might affect the functioning of the sensors that is collecting those signals, or some devices that is collecting those signals, like power signals or voltage signal or any smart meter.
Yeah, so because in this case I said voltage signal, so so you're right, because those signals will be collected with the help of sensors. I mean those RTU, PMU devices. So therefore you are right. So everything will be affected. I mean affected in the sense that those devices cannot properly understand what type of signal is it. Because typically those signals are designed to understand the sinusoidal signal in case of AC system and to understand the DC signal in case of DC system. But once there is harmonics, it's kind of the mixture or combination of DC and AC, especially with higher order frequency. So that's, for example, you have a controller. Controller has a reference value, 100 volt, for example. But with that signal, because there is harmonics, it is difficult for that controller to understand whether it is 100 volt or not. That is this means that controller cannot function as expected, and the impact will go on the overall gate. So the appropriate answer is yes, the harmonics will adversely influence or adversely impact or negatively impact the functionality of the controller and hence the overall power grid. So again, once again, like I am going to write down the answer and post to you for your further looking and understanding. Okay, so everybody see question number 2. I think in last class, Naif was asking me about these questions. So question was, what should be the input and output variables to design controllers for an automatic voltage regulator, which is called AVR, and a governor, which is called GOV systems, for a synchronous generator, which is located in a smart grid system? And then explain your answer. So what did you write to the answer for this question?
So for both of them, I mean, there would be the input would be the error signal. For the first one, AVR, error voltage, and for the second one, governor, I wrote speed signal, error in speed signal.
And,
That would be the input.
and what should be the output variable?
So output would be the some signal, some control signal that control the actuators or something like that.
Okay, so you are almost there. You see, if you see the third slide, probably you remember that once I shared you these two models, automatic voltage regulator and governor model. And that is the reason I asked you that, okay, you will find out this slide and you will get the appropriate answer there. So therefore, what you said, Manoj, like you are right. In case of the AVR, because it is automatic voltage regulator, you need the error signal. In this case, VTO is the reference signal, reference voltage, for example, 100 volt. And then VT is the measured voltage from the system. So therefore, you will see if there is any difference or not. If there is any difference, then that will be progressed through this control system. And finally, it will produce the field voltage. You remember that before I told that EFD means field voltage. Basically, that automatic voltage regulator system controls the field voltage. That ultimately controls the any voltage error. So therefore, the appropriate answer would be you have to choose voltage as the input signal or voltage error as the input signal, and field voltage should be the output signal. Then similarly, because this is for the governor system, governor controls the shaft speed by controlling the mechanical input power. So P is that mechanical power. Then if it is gas turbine, then gas is that mechanical power, or nuclear turbine, whatever, or steam turbine. But because the function is to control the shaft speed, so you have to take the speed as the input. But that Manoj said, error of speed here. So that Omega M0 is the reference speed. For example, 3600 RPM for a standard synchronous generator. And then Wm is the measured speed, whatever speed is coming higher or lower. If there is any change, then that will be compensated and it will produce the required mechanical power, P. So the appropriate answer would be input signal should be speed or error of speed, and output should be the mechanical power. So
Dr. Ali,
yes,
in figure 2, we are controlling the mechanical power by controlling the fuel that we are using to move the shafts, right?
exactly.
So basically, this is like a valve system.
Yes, valve system. So
Okay.
therefore, when I am controlling by looking the speed, I am controlling the mechanical power means, then you are right. I have to open and close the valve. I have to control the flow of gas. I have to flow the control of steam. That is the mean. Or in case of the nuclear turbine, like the uranium and plutonium, that is the meaning. So ultimately, by opening and closing valve, you have to control the input, and that will control the mechanical power. And ultimately, that will control the shaft speed. That is the meaning. And as I said, in this case, you will be controlling the excitation. Field voltage mean you have to control the DC voltage, DC excitation. And that will ultimately balance the voltage if there is any change. And that is the mechanism for the synchronous generator. Those features are not available in wind generator or in any induction machine system. These two features, keep in mind, these two features are only available in the synchronous machine system. And these are pretty like realistic situation. In every power plant, you have the AVR and governor model. Okay, so now moving forward. See, question number 3. Consider a microgrid system that consists of a wind generator, a synchronous generator, an energy storage system, and several loads. Again, for example, that type of system that I showed you had. But the question is, you find that a capacitor is connected at the terminal of wind generator, but you will not see that at the terminal of synchronous generator. Explain the reason behind this. So what did you write as the answer?
I wrote like wind generator, mainly people use induction machine, and induction machine draw Q because it doesn't have a magnet. So we need to do other capacitors to correct the power factor to improve power quality.
And but why not at the synchronous generator? Or did you write for that?
Because synchronous generator has magnet inside it, so it doesn't draw Q from the grid, so power factor does not drop.
Okay, yes, so the right answer. So everybody see, because you have seen before that wind generator basically based on induction machine, and induction machine always requires to draw or to take power, especially the reactive power from the connected grid system. That's why there is low power factor issue, reactive power issue. You have to compensate with the help of a capacitor. On the other hand, like as Othman mentioned, that for synchronous generator, it does not require power from the connected grid system because it has already the physical magnetic poles. In addition, it has that like AVR and governor system, so it does not require any capacitor to be connected. That is the like appropriate answer. So it looks like you all have written the proper answer. Okay, the next question, how can customers participate in a smart grid network? So what did you write?
I said like in smart grid network, customers can know what is the future price, and based on that, they can put loads to the system or not. And on the other side, for the producing company, once the loads are high, they increase the price, so they let people take off the loads.
Okay, so any other answer? Manoj, what did you write?
Yeah, I wrote two things. The first thing is there would be the bidirectional power flow. So the customer can buy the electricity from the grid, or they can be a prosumer and produce electricity, and they can sell the excess energy to the grid. That is the first thing.
Mhm.
And the second thing is the bidirectional communication, from which they can see how much power they are using,
Mhm.
and they can, I mean, schedule the load and all those things from the intelligent. I mean, they can make some intelligent decision based on those, I mean, power of those smart meters from the bidirectional communication.
Okay, like so both of you, like you are there, so your answer. Uh, like more appropriately, I would tell that customer participate in smart grid through smart metering. For example, smart meter is the device through which, because it is, as you mentioned, Manoj, because it is bidirectional system. So with the help of smart meter, you will get all information, like including price information. Similarly, through your smart meter, the utility or the distributor will get your power consumption. That is one thing. And then we will be discussing today through demand response. So therefore, the appropriate answer would be through demand response on through smart metering. But what you all have explained, those are also the correct answer. So today we'll be discussing the demand response, that how the customers participates through demand response program. The last question was, can smart meters connected to customers be affected due to harmonics in the power grid? Explain your answer. So what was the answer you wrote?
I wrote it, I mean, there would be effect on the smart meters because those smart meter has certain, I mean, TSD ratings. So beyond that capacity, the smart meter may malfunction or give rise to some uh, wrong data. That's what I wrote, but I don't know. I mean, smart meter has that capability to deal with the harmonics and all those things, but I wrote that thing.
Yeah, so like if you are there, answer is there. Uh, you know that smart meters are designed to consume the power, basically the real power. Now, if there is harmonics, then what might happen, because we are talking about smart meters. So because of the harmonics, because smart meters are designed to consume real power with sinusoidal signal. Then again, because harmonics are entering there are undesired signal or oscillating signals. So smart meters might not understand those, consequently might provide the wrong reading or the wrong output. That is the answer. So in other words, that smart meters performance could be affected due to harmonics. The consumer reading might not be correct because of the higher order frequency signals. As I said, smart meters typically are designed to consume or to take only the sinusoidal signals. Okay, so I'm on the way of looking and reviewing your answers, and then and I'm going to write down the answers for these questions, and I will make these slides available. Okay, so therefore, regarding that question number 4, customers' participation in a smart grid network, today we will be discussing those things. So everybody see that is the like slide number 4, the demand response. So what does that means? Demand response means response of the customers, because you know demand is related to the customers. We consume power as a customers and we get the demand. So response means we have to respond with the situation of the electric utility. It can be like in terms of price. Now utilities send you a signal through your smart metering. Hey, electricity price is high now. They respond you because the price is high. So don't use many of the loads, or if possible, shut down some of the loads that you can turn on later. Or you got the message, now there is not enough electricity produced. Now there is not enough energy. That time you have to respond. Again, you have to respond, you have to honor them because there is not enough electricity. Try to reduce some of your loads. That is the meaning of demand response, meaning that customer responds with respect to the price information or with respect to the electricity production by the utility. So that's why everybody see I have written demand response can be defined as the changes in electricity usage by end users customers from their normal consumption pattern with respect to or in response to changes in the price of electricity over time. So therefore, utility will make available this information and accordingly you have to respond. That is the demand response. Or sometimes you might see the definition, demand response can also be defined as incentive payments designed to induce lower electricity use at times of high wholesale market price or when system reliability is jeopardized. So this means that electric utility might send you information, hey, at this time price is very high. Please try to use as low power as possible. And if you do that, we will give you some incentive at the end of the month. For example, okay, 20% reduction of your electricity bill. So there are two things. One is like price. First definition is goes in terms of the price. Second definition in terms of incentive. Okay, please don't use much power at this time. Then I will give some incentive. So that is called the demand response. So simply speaking, demand response means customer response to the utility. What utility is telling? Either price is high or low or there is not enough power. Accordingly, you have to respond. That is the demand response. Now, so moving forward, here you see next slide. What are the features of demand response? I mean, again, the same definition in detailed format. So there are three general actions to achieve that customer response. And each of these actions involves cost and steps taken by the customer. So what is that? First point, customers can reduce their electricity uses during critical peak periods. I mean, typically during the noon, uh, when prices are high, without changing consumption pattern during other periods. I mean, you don't change anything, you use everything, but you just try to reduce your electricity consumption. For example, in a summer day, very hot day, you are using your HVAC, air conditioning system. Instead of setting at 75 degree, you set at 80 or 82. You feel a little bit hot, but try to use less consumption. That is the meaning. Or you are about to cook, don't cook at that time. So or you turn off the television or some unnecessary, I mean less important or less necessary things. That is the meaning. Reduction of the electricity usage. Second point, customers may respond to high electricity price by shifting some of their peak demand operation to off-peak period. For example, because the electricity is high, you think which things is not important. For example, you don't start your dryer and washer. You fully shift it in the evening. Or, I mean, don't cook at that time. Yeah. So accordingly, like you have to control your pattern. That is the meaning. So the second point means you are not using the some of the your appliances at that moment. You are fully shifting. First point means okay, you are using, but you change the set point. You control with the regulator so that you consume less amount of electricity. The third point is that okay, there are customers who have their own distributed generation. For example, although you are connected to utility, you are connected to MLGW system, but still you have solar power on rooftop, or you might have a small wind turbine at your backyard, or you might have a small diesel generator. So during peak time, you can turn on those. So this means that said that by utilizing on-site generation, customers may experience no or very little change in their electricity usage pattern. You are not changing anything. However, from the utility perspective, but because you are using your own rooftop solar or wind or your own system, what utility will see? Utility electricity pattern will change significantly because they can understand from their meter that you are not using. So that will change their electricity pattern and demand will appear to be smaller. So they will see that, okay, I am producing electricity at my power plant, but consumers are not using. That will also change the pattern. That is the meaning. Okay, so the moving forward. So effect of demand response on electricity market price. So you all know that if the demand increases, definitely the price will increase. So x-axis is demand and y-axis is the price, dollar per megawatt hour. So as you can see, until a certain point, it is kind of the fixed rate or flat. But once you know that demand increases, price is started like exponentially. And it might happen, you see, in this zone, but drastically change because this is exponential. And there is on, that article in California, there is an electricity crisis during 2000 to 2001. The reason is not clear, but there are some sort of crisis in the PG&E system, Pacific Gas and Electricity System. And at that time, what happened? If they reduce the demand just by 5%, that resulted in 50% price reduction. I mean, because of this pattern, that is the meaning. So in other words, this figure shows a small reduction in demand will result in a big reduction in generation cost and in turn a reduction in price of electricity. Now, as a customer, for example, you need 10 megawatt, just an example, you are a small industry, 10 megawatt. If you say utility, okay, I need another 5 megawatt suddenly, then it is problematic for them because they have to produce that extra demand or extra power. And they need engineers, they need operator, they have to turn on another small unit. So the costs come in that way. That's why they have some sort of range. Okay, until that range, it is flat or little increase. But after that, if you want more power, more consumption, the price will change drastically because you are keeping those people busy. They need manpower. They need some sort of small generators to be turned on. That is the meaning. Now, here I'm showing the example of from the standpoint of your home. You see this figure shows a smart home with a home energy management system. So EMS stands for energy management system. So why I am bringing this example? Because smart home definition means your home is a smart and it is powered by, you see, on rooftop solar or a small wind turbine. And also your home is connected to power grid and it is of course bidirectional. And this is that home area management system, your main control system. And you see at the entrance there is a smart meter. And the assumption is that all of your appliances and loads are smart. And you see those are like bidirectional. And even there can be plug-in hybrid electric vehicle system. That is the feature of the smart home as well. So therefore, as you can see, right side I have written, the smart meters provide great information. I mean, those information, whether electricity price goes high or not by the utility. And those are beneficial for both utilities and customers, such as home load profiles and dynamic price signals. So your benefit having the smart home, that through the smart meters, you are getting dynamic price signals. Continuously you are getting price. Is it flat or it is increasing or decreasing? Accordingly, you have the choice to control your loads. And the benefit of the utility, they are getting your home load profile. They are looking your consumption pattern. Accordingly, they are they are monitoring whether they need to turn on any new device or not, or that is fine. So they can also run optimally their system, and you are also making a trade-off by turning on, turning off, or by controlling some of the appliances with a view to reducing some your price cost. That is the meaning. So I think everybody is fine so far. These are pretty common things that you all know from your general sense as well. So then moving forward, and again, then I am again and again like explaining in different way the same concept, demand response. So what are the main objectives of demand response? So there are a couple of points. Main goal of the demand response, reduction of the total power consumption. That is your main goal. So that the mutual profit for the power utility and consumers is achieved. Both parties should be benefited. And this reduction should occur not only in consumers' demand, but also in the losses of the transmission and distribution system. Now, you are thinking from your home, you are reducing the electricity consumption with a view to reducing your monthly bill, but also with that you are helping to reduce the transmission and distribution system loss. I mean, you know that from the utility you are getting power through the smart meter. This means smart meter, you are taking basically the current. Voltage can be the same, but you are getting various current, so I. And those I is flowing through the transmission and distribution lines. And you know on the distribution and transmission lines, there are basically R, resistance, and the X, reactance. So therefore, you are drawing more current, you are drawing more power means you are causing more loss, I square X and I square R loss. You are drawing less current means because those are non-linear, significantly it is reduced. That is the meaning, that the total power consumption reduction is not only in terms of the consumer and utility, but also benefit is getting in terms of less loss on the transmission and distribution system. So that is the total power consumption reduction. Next bullet, reduction of the total needed power generation. So similarly, this is vice versa. If the consumers need less power, this means power plant, power operators, utility needs to produce less amount of power, which is the main result of the aforementioned objective. And what does that mean? You see, under the successful implementation of a DRE scheme, the need of activity extends it to run power plants to meet peak demand is eliminated. You know, as I told you, it is actually expensive to turn on even a single power plant because you need power operator, you need engineer, you need fuel, so that incurs a significant cost. So because you are reducing the power consumption and hence you are reducing the total power generation, that is ultimately eliminating or reducing the unnecessary expensive to run power plants operation. Now, third bullet you see, change of the demand to follow the available supply. From your home, with the help of a meter, you can follow the trend of the power supply availability, especially if it is a renewable base, solar panel and wind. So you know that in case of the solar, if it is cloudy day or if it is at night, it is not producing power. Or the sun is peeping through, it is getting high, the intensity is getting low. So you are understanding that pattern. Or wind turbine generator depends on wind speed. So sometimes there is high wind, sometimes very low, sometimes it looks like flat. So you have to follow that power supply pattern. Accordingly, you have to adjust your system, your usage, and that will improve the overall power system reliability and stability. That is the meaning. And then the last bullet is reduction or even elimination of overloads in the distribution system. Customers, we all are connected to the utility through the distribution system. So therefore, you are consuming less power, you are controlling it, meaning that you are reducing the burden or loading of the distribution system. And in the context of smart grid, there is DMS, which is called distribution management system. That is basically, it's located in distribution substation that continuously monitoring the status of distribution system, and then it is adjusting. And in that way, it is making and enhancing the reliability of the system. It is kind of the DMS provides real-time decision, real-time control, continuously watching the situation and accordingly monitoring. So these are the like overall or the main objectives of that demand response program. So now a little bit more about that. So once I was looking on Department of Energy on report, uh, they have classified demand response program in several categories. So demand response program, mainly three categories. Demand response based on control mechanism. And then here you see again there are two: distributed program, centralized program. So you all know this concept. It can be centralized control system or it can be distributed control system. Okay, demand response can be based on offered motivation. What type of plan utility is offering to customers? I mean, we already discussed. It could be price based or it could be incentive based. Then demand response could be based on decision variable, like okay, task scheduling based or energy management based. Task scheduling means you can defer some of the loads to use at a later time when the electricity price is low. Or energy management, okay, you have a sophisticated energy management system, intelligent control system that will automatically look the price, every information, and automatically it will adjust. So therefore, the Department of Energy classifies demand response programs in that way. But I mean, in general, the goal is the same that we already discussed. I mean, consumption reduction, power production reduction, and overall cost reduction. And then again, already we discussed these things: demand response, benefits, and costs. So again, this is one of the report as offered by the Department of Energy. Demand response benefits, participant benefit, market-wide benefit, reliability benefit, market performance benefit. Like participant, we already told incentive payments or your saving bill, market-wide price reduction, capacity increase because you are using less consumption. Power plant or power utility can reserve their capacity, so avoided or deferred infrastructure cost. System is reliable because it is reducing outage, because consumer are properly following the supply as provided by the utility. And customers, participants, diversified resources like solar, wind. Market performance reduces market power options to customers, reduces price volatility. So, I mean, in other words, all of that goal goes to that overall power consumption reduction over power generation, and hence save the price, make a cost-effective system. That is the meaning. Now, because we looked that hybrid electric vehicle in that smart home system, so that is one of the governing parameter or governing component in the demand response program. So here, you know, in this slide, just I have written very basic things that you all know, everybody knows. Hybrid electric vehicle, or it is called plug-in hybrid electric vehicle. Because it is hybrid electric vehicle, so you all know from the basic concept, it is the combination of gasoline power and electricity that uses for its operation. And then idea of the hybrid is to increase gas mileage and reduce pollution. I mean, use more electricity and try to use less gasoline. That is the meaning. And then in the typical hybrid vehicle, the gasoline engine gets powered from traditional gasoline and then electric motor from a battery. And hybrid electric vehicle means that you have to charge that battery, and then motor and engine are together to provide power for that car or vehicle. An electric motor runs the car when it is in cruising or decelerating mode, and gasoline power engine powers the car when extra power is needed, like during acceleration, accelerating mode. And then again, the overall goal of that hybrid electric vehicle to use less gasoline power and run the vehicle with the help of electricity. In that way, hybrid vehicle uses less gasoline and produces less emissions as compared to a vehicle that uses full gasoline power. So this is the basic concept. So now what that PHV does in terms of the power grid, because it is the case of the plug-in hybrid electric vehicle, you have to charge your battery to run as a motor, especially during cruising mode and deceleration mode. But what is the impact of that plug-in hybrid on power grid? So here you see, I have written that thing. Now, in one hand, that is getting a very popular concept, plug-in hybrid electric vehicle. And not only it impacts the transportation, environment, and economy, but also it impacts the power industry. How it impacts? In one hand, when you are when you are charging your car, you are not introducing it as a new load, but also it is introducing new load big times. So, however, it is not always like that. PHV has negative impact, and you don't think that okay, it is consuming power. That is not the point. That's why I have written PHV does not negatively impact power system. It can also help improve the stability of the modern, highly diversified generation portfolio system. I mean, how it help? So take the example of in the IC I have shown in blue colored bullet. So variable renewable generation source like solar photovoltaic system and wind turbine system. What is the unique problem there? Unique problem there because they are dependent on intermittent variable input sources. So they cause some power stability problems in terms of frequency and voltage and power fluctuation. So there PSV might have some role. For example, at your home, you have the photovoltaic system and wind system, and you are getting fluctuated output. Now you have a hybrid electric vehicle parked at your car. So what it can do? It can work as an energy storage device. I mean, the way we discussed energy storage, exactly. And that PHV have a bidirectional handling capabilities. This means it can work V2G mode, vehicle to grid mode. You can transmit power to grid. You can minimize fluctuations that is resulting from PV and wind system. That is the meaning of V2G mode. And during charging, you are taking power from grid. So that is the grid to vehicle mode. So this means these vehicles can be used as effective energy storage system to mitigate frequency and voltage fluctuations that is coming from PV and wind generation system. This means, in other words, that PHV system can be considered an effective control means or methods to augment the system or the stability and the reliability. So therefore, if you are asked what is the negative impact of PHV on power grid, so negative impact is that because it is consuming power, and then if you simultaneously start charging from many cars, from many electric vehicles, then there might be some voltage reduction issue, voltage issue. But on the other hand, when it is needed, it can work as a good energy storage source. So therefore, I think in the next slide, I have written all beneficial point. You see, a PHV can be considered as a generation source with or without renewables for a home microgrid. For example, your home may not have renewables. You charged your car from outside charging station. We're assuming that in the coming days, in the very near future, there will be lots of electric vehicle charging station. So you can say that once you park your car, it is at night, you are at home, it can be a good, a small capacity generation source. And then, for example, your home is connected to the main utility grid system. In case of Memphis with MLGW system, But for example, there is some sort of fault and the line got disconnected. That time, if you have a PHV system, then still it can power your refrigerator, heating, cooling, lighting, and some important appliances because it has the battery. It's a PHV has basically the DC power, and then with the help of inverter, it will convert into AC power. So for a small time, maybe 30 minutes or 1 hour, you can use. So, and then, as I said, that in terms of commercial applications, day by day, the amount of PHP are getting increased. Consequently, in the near future, you could see lots of charging stations that will replace the current or the existing gas fueling station. So that's why I would say that PHP is like more beneficial than detrimental. Only effect that in the charging station, when many cars will be charged simultaneously, there could be voltage side or voltage reduction issue. But I think, in my opinion, in the coming days, because the sophisticated charging station, or there will be enough reserve capacity, there will be enough solar and wind power charging station. So even if you connect lots of cars simultaneously to charge, but still I don't think there will be voltage reduction issue. Okay, so everybody is fine so far? Manoj, I think this information will be helpful for your research.
Yes, Dr. Ali.
Yeah. Although like your goal is cybersecurity, but still this basic information will
Right.
help you to design the mitigation technique for the cybersecurity issue.
Absolutely.
It's kind of how the system operates, what are the benefit, what are the negative side, etc. Okay, so moving forward, today I like to start a new topic, which is that cybersecurity issues and solution for smart power grid. And that will be our kind of the last chapter for this course. So today I will discuss something and then I will continue in next class. So the question is why that cybersecurity issue is coming in the smart power grid. So how that cyber attack happens in power grid. So I think everybody see the next slide. I have given the title like how cyber attack happens in the smart power grid. So everybody see in the caption of the figure, I have said cyber physical system, and in parentheses I have written DC microgrid system incorporated with the SCADA. So just keep in mind, like every power plant is the best example of cyber physical system. We are telling it cyber physical system, that definitely, this power grid, in this case DC grid, and each component are physical device. But those are being controlled with the help of some sort of algorithm, some sort of cyber information, or the SCADA is basically, it is a decision maker. There are lots of algorithm controller or logical controller in terms of software. Those software part or logic algorithm, those are called the cyber part, and then these are the physical part. In that sense, any power grid, whether it is DC grid or AC grid or hybrid grid, that is the best example of cyber physical system. Now, assuming that this is a cyber physical system, what this picture is showing, on top I have shown SCADA, supervisory control and data acquisition. And at the bottom, that DC microgrid system, it has distributed resources, as you can see, wind, solar, fuel cell, and storage system. There are various types of DC load, even AC load, and that is the common DC bus. Now, as you can see, these arrows, bidirectional arrows, as Manoj said today in answer to one question, that smart grid has bidirectional capability, and you all know that feature. So this means SCADA, with the help of various router or communication devices, they are communicating with each and every component in the DC microgrid system in bidirectional mode. Now, while this is the system, there is computer, there is algorithm, there are various controllers, there are bidirectional communication media. That's why anytime cyber attacker or anybody may take the chance to impact or to destroy any of these components by intruding through the SCADA. Like someone is working here, even some employee or some ERCOT, someone is working here at the SCADA station, and they may send any bad signal, or they may create some sort of jamming, or they may fully damage any of the component just with the help of the communication and then computer software. So that's why the question is how cyber attack happens, because you know the definition of a smart grid. It has internet-based connectivity and it has bidirectional communication capability. Just, I mean, simply take rule of thumb. If any system has internet connectivity and communication issue, then of course there is cyber security or cyber hacking issue. So in that sense, in the DC microgrid or the cyber physical system or any power grid system, it is highly likely that there will be cyber attack or cyber hacking issue. Now, why are we studying that topic in this class? Because this is very important. So therefore, to understand the importance of that cyber attacks, first let's have a look. What is the consequence? What are the negative impact that cyber attacks might have on power grid? So just I have mentioned some incidents. You know, and these days there are lots of incidents, but some very well-known and important incidents. First one is like Stuxnet. Like if you just Google, you will get explanation about it. It happened in 2010. And what it did, it targeted SCADA system and programmable logic controller, which are called PLCs, and that caused damage to Iran's nuclear power plant system. That is Stuxnet. It basically someone was trying to test a software and that damaged the nuclear power plant system. Other one is called, just 1 year later happened, it is called Night Dragon attack. It happened 2011. Again, it targeted SCADA system and that affected 71 organizations in China. And then ransomware attack, it happened in 2017, June. It targeted many organizations, including Ukraine's electricity company. And 73 megawatt of electricity was not supplied. It affected. And then even after that, one attack called the Aurora attack. Aurora attack is type of malicious command injection attack that opens, closes critical component like circuit breakers without authorization. So you all know that on power grid, on transmission and distribution line, there are circuit breakers. And typically circuit breakers opens and close depending on the need. There is protective relay system. That relay system first understands if there is any disturbance or faults in the system or not. And if the current rating exceeds the threshold rating of the circuit breaker, that it opens. And again, within a certain time, again it recloses. That is the typical function. But Aurora attack means someone is sending the bad command, malicious signal, so that protective relay is understanding that now I have to open. So unnecessarily it is opening and then it is closing. That is the meaning of the Aurora attack. And again, there is another attack. It is called crash override attack. Again, this is with regard to circuit breakers. It malfunction. Again, someone is sending just bad signal. It is not the time to open, but it is opening. It is not the time to reclose, but it is closing. This means it is maloperating, malfunctioning, and ultimately it is destroying the power grid. Because if you can, disconnect the power line, then consumers are getting under dark. They're getting deprived of power. And then that will cause instability even in the power plant. The generators will be unstable. So both customers and then utility power plant will be affected. So that's why, because of these instances, and you don't know that what is coming in the coming days, there can be many other severe example even as compared to these things. So these are the reason, these are the instances. That's why it's making these cybersecurity issues in modern grid or smart grid system very timely and very hot topic. And that's why we are covering uh, even though in a small format in this class. So in the next slide,
Dr. Ali,
yes,
in cyber attacks, we mainly want to protect the SCADA first thing, right?
yeah. mainly
One priority for us.
the intruder enters through the SCADA, and then they can reach the component level. So, okay, see this one. This is the main target point here, because there are lots of computers connected with that SCADA. So intruder will enter through the SCADA and then can reach the component level. So, Othman, so maybe you wanted to say something else?
But Dr. Ali, like when people attack the circuit breaker, the only thing that you put people in dark, right?
Circuit breaker, what?
When we attack circuit breaker, the only thing will happen that people will be in dark, right? Like
Yeah,
there is
yeah.
no other cost to it.
Yeah.
So if this happen, like there will be a manually solution for this, right?
Yeah, so therefore, if they destroy the circuit breaker, for example, it is continuously opening, closing, then the, that internal devices or the protective relay or coil might be damaged. Then next time you might need to go there physically and you have to fix it physically.
And if they do the cyber attack, they can open and close circuit breaker without allowing time delay, Dr. Ali?
Yes.
They can do that, right?
Yes, they can.
Okay.
And then, like in continuation to your question, I mean, because you are saying they can do that, who can do that? Those who have a good knowledge about the system. Who knows well the circuit breaker operating principle. For example, you are an engineer, you are working in a power plant or a substation, you have a good knowledge about circuit breaker, you know how to close and how to open it, when to open, when to close it. So you have some bad intention for some reason, and then you send some bad signal to the circuit breaker with the help of SCADA, because you know the operation. Same thing, for example, today we are looking at AVR and governor system.
Mhm.
You know what is the input, what is the output.
Yes.
You just set some wrong set point of the voltage. In the governor, you set some wrong point, wrong speed, because you know the system. Anybody cannot do that. Like other student, like arts students, commerce student, they cannot damage these components because they don't have good knowledge. They can just physically damage. They can just take a hammer and they can hit and they can damage the system. But you power engineer, you have a good knowledge. You know, okay, there is a inverter here, there is a converter here. Let's send some bad signal to the inverter or converter, because you are intelligent enough to destroy the system. That is the problem. I think you understand now, yes. So
Yes.
here I'm saying, any question from anybody? Okay. So here is just an example. What is the effect of cyber attacks on power grid? So everybody see this example. This is again this example. I said voltage at PCC, point of common coupling. Today I showed you one diagram. I think this system. This is that PCC. This point, PCC point of common coupling. So at this point, I measured that voltage, and that is the example I'm showing you now. What happened? The voltage initially it is close to 1 per unit, and it is okay, running fine. At 3.5 second, I have written it here. At 3.5 second, I injected a bad signal. Basically, I injected a bad signal at the SCADA, at the energy storage system. And once I sent the bad signal, basically energy storage got disconnected. So there is no good support, good balance. And I continued until 5 seconds. So my duration of attack is 3.525. So therefore you see first voltage going down and some oscillation created, and system became so unstable so that even if the attacker is removing the attack at 5 seconds, still the system did not go back to the original situation. So this is the very worst example because already system got unbalanced. So even though the intruder removed the attack after 5 points, but the controller could not respond properly. Energy storage could not respond properly because already voltage level has gone down. So you need the error signal in control of the energy storage. That could not work well. So consequently, until the end of your simulation time, 10 seconds, it is like fully collapsed situation. So therefore, even if, for example, it is not collapse, even if it just like oscillates, in that way, that is also the bad in terms of the power grid. Okay, so then from now on, today we will not go that long because I will continue in next class. Here I like to show you so far, according to the literature or various reports, there are about 10 or 11 types of cyber attacks that happened in Power Grid. So I have written the description for it. The first one is called Distributed Denial of Service, DDoS attack. So, these attacks are mainly used for disrupting, blocking, or jamming the flow of information through control and communication network. And recently there has been an increase in DDoS attack with shorter attack duration, but a bigger packet per second attack volume, which not only exploit bandwidth, but also attack application that focus on sending bad traffic using those applications protocol. And this type of attack can drastically disrupt the communication in the microgrid cyber infrastructure. So this means, in summary, the DDoS attacks create some sort of jamming or blocking, and that can introduce significant amount of delay in the system. Huge delay. And we all studied the impact of communication delay on the system. Delay degrades the performance. So DDoS attack is basically creates the jamming, the flow of the data, flow of the package. It delivers the signal significantly late. That impacts the system. So here just I have one flow diagram how that DDoS attack works. Everybody see on top I have written DDoS cyber attack has 4 basic components: attacker, handlers or controllers, bots or agents, and target. So everybody see on top this is the attacker. Attacker is ready with on good laptop or good computer. It has various types of software that can destroy system. At the bottom you see like you are the target point. The attacker want to target you. So how it is going? Attacker is first sending a signal to controller, and controller is that handler. It is basically there are other types of control device and the computer there. And then those you see the attacker was one, and it used 3 controllers, n number of controllers, for example. And then those controllers are again sending signal to bots or agents. And as you can see in the picture, those bots and agents again have various types of computer with included software. So then what happened, these bots or agents, they do not understand anything. They just fully follow the command by the attacker, by the controller. And they get message, okay, send some signal to the target. You see, continuously signal is coming. So now one of the best example many times happen in our case, like you are receiving email from, for example, 100 or 200, the same content, same subject. That is the example of DDoS. And for example, it looks like you are getting a good message from your known person, a good email, and then you clicked it, you did not finish reading it, again you are getting another one, again you are getting another one. In that way, at some point, your inbox or your computer system fully got freezed and you got hanged. That is the attack. That means that they attack traffic. They create jamming in the flow by sending continuous signals. It's the same, maybe the same message, but some lots of the same message. That is the meaning of that DDoS attack. And this is the so far reported as the worst attack in the power grid so far. And then the second category is called bad or false data injection or tampering communication data or signal. Now, in this case, this type of cyber attacks not only delays signal communication, but also pollutes the data in the communication. This means that, again, going back to that AVR and governor control box, for example, you need the voltage signal or you need the speed signal. Now, in one hand, those signals are getting delayed, and the reference point for the governor, the speed reference, or in case of AVR voltage, you put wrong number. So it should be 100 volt, but you put 1 million volt, or you put some negative voltage. That is called the bad data or the false data injection. So therefore, your controller will work, but controller will work fully in a wrong manner, completely malfunction or misoperation. Consequently, the power grid will be impacted. Then the packet drop attack. Now, packet drop attack can be triggered at various choke points in the communication path like links, firewalls, proxy server, encryption devices, routers, switchers, etc. So I was showing you that example of this one. There are various, router or server, various communications system here. And then these are the component. Now, attackers might attack here, attacker might attack here, attacker might here. This communication means some sort of signal is coming or going there in terms of a packet. Now you can delete that packet or you can fully destroy that packet. So that is the meaning of that packet drop attack. Now, moving forward, there are other several types. I think I mentioned about 10 types today. Eavesdropping attack. What is that? In eavesdropping attack, an attacker may intercept any information communicated by the cyber physical system. And in this type of attack, the attacker does not interfere with the working of the cyber physical system, but instead just observes it operation. This is mean that silently, for example, silently someone watching you, someone monitoring you, someone is not, hitting you or someone is not interfering you, just collecting some important information. That is the meaning of this. This attacker is not directly impacting the cyber physical, but just collecting information. It is just interfering for future interference or for future damage. That is the meaning of that eavesdropping attack. Stealthy deception attack. For this type of attack, system components or data is tampered with, and the deception could not be detected by the system detection system. Like someone has stolen something. You just know that someone is stolen, but you don't know who has stolen your things or your stuff. That is the meaning. Compromised key attack. A compromised key refers to a secret code obtained by an attacker to interpret secure information. So this means that someone has hacked your secret code or passcode or the password. And what is the goal of the attacker? Attacker can secretly gain access to a protected communication, decrypt or alter data, and try to use that compromised key to handle additional compromised key. And man in the middle attack. In this case, false messages are sent to the operator and can take the form of a false negative or false positive. For example, again, the Oathman, moving back to that circuit breaker example, it is running well, for example, And suddenly, in the middle of the operation, someone sent the bad signal. Protective relay system got the message, okay, now there is fault on the line, so you get it open, which is not true. Or circuit breaker got opened because of the valid reason, really fault, and then it is not time to reclose the breaker because you have to allow some time, but you send the bad signal, you receive the bad signal, wrong signal, now close, then you close the breaker, that will also destroy the system. Kind of the hamper during the middle of the operation. That is called man in the middle attack. Then moving forward, jamming attack. Again, this is, pretty much similar to that first one, DDoS attack. An attacker may jam the wireless channel between sensor nodes and remote estimator in a cyber physical system. Just your intention is to just create some problem, just create some sort of jam. That is the meaning. Then Aurora attack, I was already telling that before. Aurora attack means it's a type of malicious command, dangerous command or injection attack that can open and close critical circuit breakers without authorization. What the attacker does, attacker sends strip and reclose commands continuously to a vulnerable breaker and forces the generator to lose synchronism with the transmission grid. As I told you, that you are continuously sending open and closing signal to an important breaker, vulnerable breaker, and that breaker is connecting to an important part of the transmission or distribution system. And because it is continuously opening, closing, at some point that will be fully damaged, fully fail, and it will disconnect a huge portion of the network. That will cause the losing synchronism among the generators. Generators will not anymore run as parallel generators, and consequently that will cause major blackout in the interconnected system. So just you are opening, closing one breaker, but that might impact the entire power grid. That is that Aurora attack. The similar to that Aurora attack, the crash overwrite attack. And this attack can misoperate or malfunction circuit breakers and ultimately destroy the power grid. Very similar, but in this case, Aurora attack, it is kind of continuous opening, closing. In this case, it may not be like continuously, you just send on a wrong signal so that circuit breaker are malfunctioning. It is not the time to opening, but it is getting open. It is not the time reclosing, but it got reclosed. That is the meaning. And then I think in the coming days, lots of type of attack will increase in the context of power grid. Like so far, I have noticed this type of attack happened in power grid. So, however, among those different types of attacks so far reported in power grid, two types, which is that DDoS attack and that false data or bad data injection attack, are of high importance. Because I have seen some report, it has been mentioned that DDoS attacks affected 80% of electrical enterprises in various countries. And therefore, it has been one of the most severest attacks. And also the bad data injection or false data injection is a threatening attack, which also may cause energy theft of the customers and users, false dispatch on the distribution process, and the device breakdown during power generation. So the FDI attack, it just sends some wrong signal, bad signal. And then DDoS attack, it creates huge jamming and significant amount of the delay, flow jam. That caused the system kind of the freeze. So therefore in next class, I will continue. I will show you some sort of attack detection technique and on mitigation technique, and a few more discussion about that cyber physical system. Then we will conclude this chapter. So is there any questions, comments? So Manoj?
Yes, sir.
So I think these things will be very important for you.
Yes.
although you already know, but in terms of the power grid, looks like I have collected all this information for you.
Mhm.
You see all of these things. Although you're looking, I mean, the electric vehicle charging station, there are other types of attacks, but in general, in power grid, these 10 types are the most, I mean, the common. Being the DDoS attack is most severest, but in my opinion, number 9 and number 10 are also very dangerous. That
Yeah, I was just looking at these attacks, these new kind of attack.
yeah. So you can look much more detail about these two types of attacks.
Sure.
I am also collecting more information, and again, as I told, I mean, to everybody, in the coming days there will be new type of attack. So whatever mitigation protection means you know develop or you build, but still attacker always try to find a new wedge of attacking the power grid. So that's why. So my guess always continuously we'll be getting the new type of attack, and then we will you know that update these informations. Okay, so today then I like to conclude here, and then soon in a day we will be getting your grade for that homework set 2 as well as the midterm exam. And again, once as a reminder, your midterm exam 3 will be held next Thursday, I think 23rd April, next week Thursday. So in next class, again, I will be giving you a reminder and be discussing a little bit about the exam. Okay, so at this point, I am stop sharing the slides. So is there any questions, comments from anybody?
I think I'm good.
Okay, thank you. So that we're hearing none. So I'm assuming that everybody is fine, and then okay. Hope you a good day, and please be safe. So see you again on Tuesday.
Thank you, Dr. Ali. See you.
See you.
Okay, see you. Okay, bye.
Bye-bye.
Bye.